Okay, so we are starting where we left off in the notes. We're on the try problem A. And it looks like x times x squared plus 1 to the oh my goodness, x squared plus 1 to the 4th power. Okay, so we're going to let u be x squared plus 1. So that means du is going to be 2x dx. Okay? Now, that means that 1/2 du equals x dx. Look.
My sheet is completely trashed. Oh, I'm sorry to hear that. It's okay. That's what it is. So now, find another.
We need x dx, which is what we have. But instead of just plugging in du for that, we have to plug in 1/2 du. So the 1/2 is going to end up going outside of the integral. And then we have u to the 4th du. So we've got 1/2 times u to the 4th plus 1 divided by 5, and then plus c. So we've got 1/2 times u to the 5th over 5 plus c. That is 1/10 u to the 5th plus c, which is 1/10. We plug u back in, x squared plus 1 to the 5th plus c. Okay, so again, we had the x, which is what we really needed. We had the x right here. We can manipulate constants. That's not a big deal, as long as we have the variable we need. Okay, next problem, B. I have x squared times the square root of x cubed plus 1 dx. I'm going to let u be x cubed plus 1. That means du is going to be 3x squared dx. But look, I just want x squared dx. So I need to get this x squared dx by itself. So I'm going to divide by 3, which gives me 1/3 du equals x squared dx. Well, this 1/3 is a constant, so by my constant multiple rule, I can plug that in out front of my integral. So 1/3 times u to the 1/2, because that's what the square root is, du. Once I integrate that, I have 1/3 times u to the 1/2 plus 1 divided by 3/2 plus c. That's like 1/3 times 2/3 u to the 3/2 plus c. This is 2/9. I'm going to plug my u back in, x cubed plus 1 to the 3/2 plus c. And I'm just going to leave it in exponential form, just like that. All right, on to part C. have a trig one. I have 2 secant squared x times tangent x plus 3 dx. Now, I know from the one I did in the last video that I need to let u be tangent x plus 3. And my du then is secant squared x dx. Now, here's where this is kind of backwards from what we were just doing. I have a secant squared x dx already in my problem, but I have this random 2 already in there, and it's already in my integrand. It's not in what I just differentiated. So what I'm going to do is rewrite it so that it's on the outside. So instead of there being a 1/2 on the outside, there's going to be a 2 on the outside. I'm not changing it. Okay? So now I'm good to substitute. I'm going to substitute du for my secant squared x dx. And I'm going to substitute u for my tangent x plus 3. So I have 2 times the integral of u du, which is 2 times u squared over 2 plus c, which is tangent x plus 3 quantity squared plus c. Remember, this constant multiple rule only applies to constants, not to variables, only to constants. We cannot pull variables out of out of the integral. Only constants. Let's do one more. All right, there's really only one thing for us to do here. And that is for us to do 2x minus 1 as our u. And that would leave our du to be 2 dx. But if you look, there is no 2 out front. So let's divide by 2. That means 1/2 du is going to be 1 dx. Which if you look closely, it's like we have a 1 right there. Forgot the dx. Okay, so 1 dx. So we have a 1/2 times the integral of u to the 1/2 du. Okay, so we've got 1/2 u to the 1/2 plus 1 over 3/2 plus c. So we have 1/2 times 2/3 u to the 3/2 plus c. This gives me 1/3 times 2x minus 1 to the 3/2 plus c. And that's where I'm going to end the video for today, or for this.